simplify exponential expressions using the division properties of exponents. Read together. 1, 2, 3. I can simplify exponential expressions using the division properties of exponents. All right, and if you guys notice here, from what we did before it was multiplication, now we are in what? Division. Division. Okay? So, think about the question. What is the concept for today? Tell your neighbor what concept we're still on. Okay? And if you forgot, we are on exponential expressions. You don't need to write this for your model. We already have it from the previous lesson, right? Just the definition. Exponential expressions are numerical and variable expressions raised to a power greater than 1. I gave you guys examples. All of these have a power greater than 1. And I give you non-examples. And we said that these two are not expressions because they have an equal sign. That's why they are equations. But right now we're just looking at expressions. This one is an expression. However, look at the powers. They're not greater than 1, right? Okay. So, critical attributes of exponential expressions, they need to be expressions only, number 1. And number 2, exponents need to be greater than 1. We're clear on this, right? Okay, let's continue. Steps, write these down, please. And you're going to see that they're very similar to the ones we wrote before for the multiplication property. Step 1, identify the exponential expression as a quotient of powers or a power of quotients. Let's identify the exponential expression as a quotient of powers or power of quotients. Step 2, use the appropriate property. Use the appropriate property. And step 3, simplify. Simplify. 3 steps. Identify the exponential expression as a quotient of powers or power of quotients. Step 2, use the appropriate property. Step 3, simplify. Things to circle on the steps. Step 1, circle the word identify. And I want you to underline quotient of powers and power of quotients. And if you notice, today we're only looking at 2 properties. Is that correct? Yes, and that's for division. Step 2, circle the word use and underline appropriate properties. And the last step, circle the word simplify. Okay, so we got the steps. Right underneath, quotient of powers properties. Quotient of powers properties. Quotient of powers properties. Okay, for this quotient of powers property, I want you to write example Q. Example Q. Example Q. Write this down. 3 to the 6th power over 3 to the 4th power. Okay, pens down really quick. So, before I do this, check this out. I'm going to go ahead and leave a space here so I can explain the why I get this simplification, okay? But I'm going to get the simplification so you can see what's going on. So here we go. 3 to the 6th divided by 3 to the 4th becomes, let's see, we got a 6, a 4, and it becomes, okay? So, turn to your neighbor, let them know what happened to these 2 exponents to get 2. Okay, copy that and leave this line like this blank so that we can explain how we get that. All right, pencils down. Here we go. So, I'm going to rewrite this one right here. Writing utensils down and eyes up on the screen. Here we go. I'm going to do the numerator in blue. 3 to the 6th means 3 times 3 times 3 times 3 times 3 times 3 over, I'm going to do the denominator in red. This is 3 times 3 times 3 times 3. Now, what do we know about 3 divided by 3? That becomes what? 1. Everybody see that? This is a giant 1. Okay? So if this is a 1, what is this one right here? How about this one? How about this one? So what is 1 times 1 times 1 times 1? 1. So we got that clear, right? So what's left? 3 times 3, which is 3 squared. Is that correct? And what is our last steps of our note? So therefore, this is what? 9. Copy that, please. All right. Now, let me show you another example, but I'm going to use variables. Copy this down, please. X to the, somebody give me a number. Okay, 10 over x to the 7. If that same rule applies to variables the same as numbers, if you can show me the work and then simplify at the end, please. All right, so after you share your notes, let's see. Who wrote, let's see, x times 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 x. Is that 10? Yes. Over x times x times x times x times x times x times x. And then we know that here's a giant 1. Here's another giant 1. Here's another giant 1. Here, 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 here. So therefore, do you guys see the giant 1 right here? You guys see it? What's left over? What's left over, guys? X to the 3rd power. Okay? So, somebody asked the question, what if we had this, Mr. Q? Okay, check this out. You're just paying attention. When you have something like this, here's the simplified version of this one. Okay, think about it. Tell your neighbor why it worked over here and why not here. Okay, so I heard you guys discussing and you said, oh, because they have to have the same base. All right, so check this out. So what would be the rule? Think about it. What would be the rule for quotient of powers? Think about it first. Think about it, think about it, think about it. Okay, volunteer, yes? Okay, close, yes? Okay, close. Over there in the front. Okay, so the rule is when a power is divided by another power of the same base, comma, what do? Subtract the exponent. When a power is divided by another power of the same base, I subtract the exponent. Let's see. Is 3 the same base as 3? Yes. Is x the same base as x? Yes. That's why all we have to do is subtract the exponents, so we got that. Here we subtract the 10 minus 7, and we get 3. And here, look at this one. These are not the same base. That's why they stay the same. Okay, let's practice these. Copy these down, please. 1A and B. Do those by yourself. Go. here we go. So, according to the property, quotient of powers property, this says if they have the same base, all we have to do is what? Subtract the exponent. So this becomes 2 to the 5th, and the last step is to simplify. We know that this is 2 times 2 times 2 times 2 times 2. So this is, let's see, 4 times 4 times 2. What is 4 times 4? 16 times 2, that's 32. Okay? For letter B, are these the same base? Yes. So this is x. 4 minus 3, that's 1. So you can write it like this, or you can just leave it as x, either one. Okay? Okay, copy these next one. Do them by yourself, please. Go. Here we go. See. First of all, let's see. We have a parenthesis here and an exponent. So therefore, here we need to first use our power of power property. Is that correct? So check this out. For every variable or number that do not have an exponent, I'm going to add an exponent of 1. Remember that? So therefore, 2 times 1 and 2 times 1 is 2. So therefore, I'm going to rewrite this down here. So this is d to the 4th, d to the 3rd, over d to the 2nd, d to the 2nd. Are we there so far? Okay, now, let's look at these. Do these have the same base? So therefore, this is d to the 2nd, because 4 minus 2 is 2. Do these have the same base? So e and 3 minus 2 is 1, or we can rewrite this as d squared e. Either one is correct. Hands, if you got that? Okay, not bad. Look at this one. Once again, we need to add an exponent of 1 to those that don't have any. So therefore, let's see. Same base? Yes, so this is 3 to the negative 1. Look at this one. Times. Same base? 4 to the negative 1. And the last one. Times. 5 to the 5 minus 3, that's 2. And if we were to square that, that becomes 3 to the negative 1 times 4 to the negative 1 times 25. Is that correct? Now check this out. This looks kind of weird, doesn't it? The negative exponents and so on and so forth. Okay, so let me take you so that we can clear this out. We're going to look at 0 exponents and negative exponents. Okay, so let's clear that out right away. Let me go to a slide really quick. And I don't know where it's at. Okay, that's fine. I'll do it here. All right. Let's look at 0 exponents first. Okay? So right now you're just paying attention. I just want to clear the air on this one. Here you go. And it's going to be so simple, you're going to be like, wow. Here you go. 3 divided by 3. What do we know about this? That 3 divided by 3 is what? 1. That we know automatically, don't we know? Okay? But right now we said with the quotient of powers property, if the numbers or the powers have the same base, what do we do to the exponent? We subtract. So therefore, check this out. If I rewrite this again, I'm going to do it over here. Whenever you see a number, what do we write as an exponent? 1 and